So in our next section, we're going to apply this idea of this summation and that series to help us with expansions. And so it's all going to be about what's known as the binomial theorem. So way back at the very start of the course, we dealt with polynomials. A binomial is just a specific polynomial where it only has two terms, hence the bi, meaning two. It doesn't matter what the powers are on each term, doesn't matter if there's multiple variables involved, there's just two single terms. So for this first one, for some examples, you could have x squared plus 9y, 4a cubed plus 8, 3y minus x. Doesn't matter those powers themselves, just the fact that there's two single terms. Our ultimate goal of this section is how to figure out how to take this, raise it to a power without actually multiplying those. Like if we were to take x squared plus 9y and raise it to the second power, you could easily FOIL that out. But what about to the 8th power? Or if you have something to the 15th power, how can you possibly go through that without that repeated multiplication, which would get really complicated and kind of gross? So to do that, we first have to talk about what is a binomial coefficient. So if you have two integers, one being larger than the other, we have this symbol NCK, which can be written in the form with parentheses as well. This is called the binomial coefficient. These two are exactly the same, so you might see either button on your calculator. But the way this is defined is in terms of factorials. So it's n factorial divided by k factorial, and then times n minus k factorial on the bottom. So this symbol can be read as n choose k. So nck, n choose k. Same thing as the n, k in parentheses, it's n choose k. It's really a way to count how many ways you could choose k objects from n things. So like if you had a bag of marbles, a bag of 100 marbles and you want to pick 5. 100 choose 5 would give you the number of ways you could possibly do that, every single combination. So let's just get practice. You do have a calculator button for this. Depending on the type of calculator you have, you might have to click the PRB button for probability, or there might be just a simpler button. But let's go through and evaluate 8 choose 5. So this is going to equal 8 factorial up top, 5 factorial on the bottom, and then 8 minus 5 factorial. So it's 8 factorial over 5 factorial, 3 factorial. So one thing, these two numbers will always add up to this top one. That's going to happen every single time because n minus k plus k is exactly n. So now we can use our properties of factorials. Remember, you can always take off the top integer and get the next number factorial. So you can take off an 8 and get 7 factorial, but nothing is going to cancel then. So take off the 7, get 6 factorial. Still nothing cancels. Take off the 6, you get 5 factorial. And that's going to be nice because you have the 5 factorial in the bottom and these cancel out. And then we'll deal with the 3 factorial afterwards. So we do have some special binomial coefficients. If we want to evaluate n choose 0, that's going to equal n factorial, 0 factorial, n minus 0. So that just simplifies to n factorial over n factorial. That's 1. So from n objects, if you're going to choose 0, there's one way to do it. You don't. Now if we evaluate n choose 1, that's equal to n factorial over 1 factorial, n minus 1 factorial. You can pull off the top n to get n minus 1 factorial. Then you have n minus 1 factorial on the bottom. So this is also equal to n. So if I have n objects and I want to choose 1, there's n ways to do that. You pick each object. If we do n times n minus 1, same thing, you get n factorial, n minus 1 factorial, then n minus 1 factorial. So those end up canceling out, and that leaves you with n factorial over n minus 1 times 1 factorial, and then you can see that's going to simplify again into just n. And if you want n choose n, that's n factorial over n factorial times n minus n factorial, which again simplifies to just 1. So there's a really nice kind of pattern that happens with these binomial coefficients. So that's going to lead us to our advantage when we actually find this when we try to do this expansion. So the binomial theorem is going to give us a nice process for actually going through that expansion using these coefficients. So if we want to take a plus b and raise it to the nth power, we're going to start with n choose 0, n choose 1, n choose 2, keep going on. And then we're going to have also n choose n minus 2, n choose n minus 1, and then n choose n. So you're going to start at n choose 0 and keep increasing that bottom by 1 until you land to exactly that value. You're going to take this first term, raise it to the highest power, and then keep reducing that power by 1 until you get down to 0. The second piece, you're going to start at 0 and increase by 1 each time until you get to n. So these two terms should always add up to the value of n. n minus 1 plus 1 is n. 1 plus n minus 1 is n. Those powers should always be what you're raising this to. So we can write this a little bit more concisely using a summation, because you can see the n is fixed. You just have a couple quantities that are changing this each time. So this can be written as the sum from k equals 0 to n. You're going to have n choose k because the bottom is what's increasing each time, starting at 0 and going to n. You have b raised to exactly that power. And then for the a, you have to the n minus k. So it's subtracting the value of k each time since it's decreasing. So let's go ahead and utilize that to expand x plus 3 to the 5th. So I definitely don't want to go through and take x plus 3 and multiply it by itself 5 times. So using the binomial theorem, your a is the x, b is 3, and the value of n is equal to 5. So you can write this as the sum from k equals 0 to 5. You're going to get 5 choose k, x to the 5th minus k, and 3 to the 5th. So it's a very algorithmic process to go through this. So we're going to start at 5 choose 0. Then we get 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. You're going to start at x to the highest power, which is the 5th, then keep decreasing it by 1 until you get to 0. Then the opposite, you're going to start at the value of b to the 0 power and keep increasing that by 1 each time. Then it's a matter of just going through and calculating each of these binomial coefficients and also 3 to whatever power it happens to be. So 5 choose 0 is going to be 1, 3 to the 0 is 1, 5 choose 1 is 5, 3 to the 1st is 3. 5 choose 2 will be 10, 3 squared is 9, 5 choose 3 is also 10, x squared, and then 3 to the 3rd is 27. 5 choose 4 is 5, 3 to the 4th is 243, 5 choose 1 is 1, and then 3 to the 5th is 243. So now just going through and multiplying everything, you're going to see this will be your polynomial once you expand it out. Now these coefficients you can see can be a little bit tedious, and they're going to be hard to kind of go through every single time. If I want to go through and do x plus 3 to the 7th power, I'm going to have to calculate a whole bunch of new coefficients. So there's another way we can actually go through that, which is called Pascal's triangle. So instead of computing this n choose k each time, we have a more convenient way to compute the binomial coefficients. So you've got a plus b to the 0. That's just a single term. Your power of n is 0. It's going to be one thing, 0 choose 0. If you do a plus b to the 1st, you're going to have 2 coefficients. Your value of n is 1. So you start at 0 and go up to 1. If you want a plus b squared, think of that's a squared plus 2ab plus b squared. You have 3 terms. You'd start at 2 choose 0, increase it by 1, up to 2 choose 2. A plus b to the 3rd would start you at 3 choose 0, increase until you get to 3. So you'd have 4 terms in this. A plus b to the 4th, start at 4 choose 0, and keep increasing the bottom until you get to 4, choose 4. And then the last one we're going to do is a plus b to the 5th. So start at 5, choose 0, and just increase that up to 5, choose 5. And this would keep going on forever. These will be those coefficients that are there. And this, you can see, creates a nice triangular shape that keeps growing. So it's called Pascal's triangle. So what we do in each of these cases, we start with a 1, because 1 choose 1 is going to equal 1. Then you're going to bring this down and branch it off. So you get a 1 and a 1. Same thing, bring these down on the outside for a plus b squared. You get a 1 and a 1. To get that middle term, you go ahead and add these numbers together. So the middle term here would be 2. So 2 choose 1 will equal 2. To get the next row, same process. Bring these outer ones down to give you a 1 and a 1. Add these together, add these together. So the next row in Pascal's triangle will be 1, 3, 3, 1. Bring them down to give you 1 and 1 on the end. Add together, add together, add together. Your next coefficients will be 1, 4, 6, 4, 1. Then for the 5th, bring these ones down again. Add these together to get 5, 10, 10, 5. So if you look at our last example, those were exactly the coefficients we had in the binomial expansion. So you could write this just once and then you're immediately done. You don't have to go through the process of calculating every single individual coefficient. So let's go ahead and apply that. Let's use Pascal's triangle to determine the expansion of this. So I've got x plus 3 to the 3rd. There's ultimately going to be 4 terms in this expansion. So I'm going to ignore the coefficients first, and I'm going to go ahead and work with just these powers of things. So I've got x to the highest power, y to the smallest power. Decrease the power of x, increase the power of y. Decrease the power of x, increase the power of y, and then same thing here. The coefficients in front, I'm going to go ahead and just go to the corresponding row in Pascal's triangle. So if we go take a look, a plus b to the 3rd will give us these coefficients. So I'm going to go ahead and just insert these in front of each term. So we have 1, 3, 3, 1 as the coefficients from Pascal's triangle. So you just use that corresponding row. So this tells us x plus y to the 3rd will equal x cubed, 3x squared y, 3xy squared, and then y cubed. So let's try another one. Let's expand m over 2 minus 1 to the 6. So here, your value of a is m over 2, b is equal to -1, and n is equal to 6. So from Pascal's triangle, we can figure out the coefficients. So we already know the row a plus b to the 5th, which was 1, 5, 10, 10, 5, 1, if you go back and look at the triangle. So to get that next row, you just bring the 1 down on each end, add together, add together, add together, together, together. So these are your coefficients. So if I want to take this expansion, I'm going to have some coefficient, the first piece to the highest power, and then -1 to the 0. Coefficient, decrease the power of the first, increase that. Coefficient to the 4th to the 2nd. Coefficient to the 3rd to the 3rd. Coefficient to the 2nd to the 4th. Coefficient to the 1st to the 5th. Coefficient to the 0 and to the 6th. So again, each time these powers add up to exactly 6. Okay? So the coefficients in front just come from Pascal's triangle. So you get 1, 6, 15, 20, 15, 6, and a 1. So then it's a matter of just simplifying each of these things because you've got to take m over 2 to a bunch of powers. So that first one will be m to the 6 over 64, -1 to the 0 is 1. 6, you get m to the 5th over 32, and this will be negative 1. 15, m to the 4th over 16, positive 1. And then you just keep going and do each of those appropriate powers and multiplications. And then the last one will give you 1, 1, 1. So actually multiplying these out, you get your finalized binomial expansion. Okay. So the very last thing we're going to do is we're going to find a particular term of binomial expansion. So if you want the r plus 1 term of a plus b to the n, it's going to deal with really 1 less as your value of r. So you have n choose r, a to the n minus r, and b to the r. So if you think of the first term, that's always going to be n choose 0 here. So it's 1 less. You start at 1, but you're really putting in 0 as that value, and you get b to the 0. The second term would be n choose 1. So again, that value is 1 less down there. So you just kind of decrease it by 1, and then use the fact that these two match up to help you. So let's go ahead and do 2 examples, and let's find the indicated term of the expansion. And so we want to start out with the third term of x minus 3 to the 7th. So here, your value of r is 2. It's 1 less than third. A is equal to x, b is negative 3, and then n is equal to 7. So you would start out for those coefficients 7 choose 0, 7 choose 1. Finally, the third term would be 7 choose 2. The value of b gets raised to exactly that second power, and then the value on the a component is n minus 2, so 7 minus 2. So we just need to simplify this out, and we'll go through and actually simplify that coefficient by hand instead of plugging it into a calculator. So you get 7 factorial divided by 2 factorial, 7 minus 2 factorial. That gives you x to the 5th, and then negative 3 squared is going to be 9. So this is equal to 7 factorial divided by 2 factorial, 5 factorial, x to the 5th and 9. So we can go ahead and pull off on that top. You get 7 times 6 times 5 factorial divided by 2 factorial, 5 factorial, and then the x to the 5th and the 9. So the 5 factorials cancel, and then 7 times 6 stays alone. 2 factorial is just 2, x to the 5th and 9. So if you go through and multiply this out, you're going to see this is equal to 189 x to the 5th. Let's do one more. Let's look at the 15th term of x minus y to the 20th power. So your value of r, because it's 15, is 1 less. It's going to be 4. The first term is a, the second term is b, and then your value of n is 20. So you're going to get 20, choose 14, the b to the 14th, and then x to the 20th minus 14. So if you do 20 choose 4, you're going to see it's 38,760. This gives you x to the 6. And then when you take y to the 3rd to the 14, you multiply the 3 and the 14. The minus sign disappears, so you end up with y to the 42nd power.